Scientific experiments from the 1850s discovered that atoms possess subatomic particles called the electron, proton, and neutron. The investigation might be too complex to understand. How did scientists discovered and proved that there is an electron, proton, and neutron? In this video, I will try to summarize the methods conducted by the scientists, making it more comprehensible for you. And will also differentiate electrons from protons, electrons from neutrons, and protons from neutrons. So sit back and stay tuned. The discovery of electrons started when J.J. Thomson used a cathode ray tube experiment. This method uses electrically charged plates and a magnet. This is what happened. When there is only a magnetic field present, and there is no electric field, the cathode ray move away from the magnet. But when there is only an electric field present, and the magnetic field is off, meaning the plate above is now negatively charged, the cathode ray moved away from the negatively charged plate. From the electromagnetic theory, basically, negative charges attract positive and repel to negative. Thus, this means that negatively charged particles exist. And these negatively charged particles are called electrons. Later on, scientists were interested in measuring the mass and the charge of an electron with great precision. It is done by Robert Millikan, and his experiment is called the oil drop method. Now there are three factors we needed to describe to give meaning to what is an electron. First is its charges, and we can fill that up as negatively charged, according to the cathode ray experiment. Next is to find the location and mass of an electron. But before that, let's continue to the discovery of proton and neutron. During the 1900s, lots of scientific discoveries won Nobel Prizes as a contribution to science. It was that time when radioactivity was a very helpful tool to the discovery of proton and neutron. Ernest Rutherford used that concept to perform his gold foil experiment. He used a new and different model of the atom that explained his experiment. From that, he found out that an atom has a nucleus. And the positively charged particles inside are called protons. However, there was still mystery unsolved by Rutherford's study. Later on, some proof was provided by James Chadwick, who discovered the existence of electrically neutral particles called neutrons. Now that the mystery behind atoms is solved, we can now fill up for each location and mass. Electron is proved to be within the cloud outside the nucleus of an atom. Electrons have the smallest mass and are extremely small. Thus, it can move around the nucleus freely, that measuring its exact speed and position is impossible. So, from scientific studies, electrons are located in that dimension of empty space called clouds around the nucleus. Protons and neutrons are packed in an extremely small nucleus. And both are quite massive compared to the electrons. The mass of a neutron is slightly larger than the mass of a proton. Now, we already know that electrons are roaming around a positively charged nucleus. Why does the rule of electromagnetism does not apply here? That is, electrons do not attract to the positively charged nucleus. This is actually the result of the strong nuclear force that is holding every subatomic particle for stability and existence.